Hello everybody, Scott Fleet here, International Radiant at the headquarters here in Chesterfield, Michigan. So today's tech session, we're going to troubleshoot the HL series. This comes in a couple different variations, HL, HL2, HL3, all functioning similar in nature, but maybe a different style power head. So for today's tech session, we're actually going to use the HL3, that's their latest series. It's a different style box. Which has made a couple upgrades as far as servicing the heater. One nice luxury is you can take the top cover off, take the side screws out, you can fold this, so you can actually do a lot of your troubleshooting while the heater's in operation, or it's much easier as the old models, you had to take the lid off, take the lid on, that sort of a thing. So for starters, the operation of the HL series heater, it is a two-stage heater, so it does require 120 volts just to power the components of the heater, and there's a fan blower inside this compartment here. But also what tells the heater to come on and off is actually a 24-volt signal. You have a 24-volt signal that activates low stage and one 24-volt signal that activates high stage. So you'll notice, and we're going to show you a screenshot on that because I can't show you right now, but there's a terminal plug on the back of this heater. It has 3 1/4-inch spade terminals. The left one is 24 volts out to feed your thermostat. The middle one is your 24 volts in for low stage, and then the far right one is your 24 volts in for high stage. So if you do have a thermostat that requires constant power, which most of the programmable thermostats do, so you could run 4 wires. And what you do is to power your thermostat, you need a common. So you can actually, there's a 1/4-inch screw on the back plate here, and you could put a fork terminal on and go in behind that screw, and then you have your constant power for your stat. So this, you'll notice this heater has a 24-volt transformer built into it, which is nice because it generates 24 volts down to your stat and back, similar to like a home furnace or a home boiler. Now, every once in a while, this model heater, they'll want to wire multiple heaters on one thermostat. So it's very important to note that there's a relay kit, an external relay that's needed, or sometimes at the factory we can have the relay added in at the time of production. So very important to note, if you have multiple heaters, let's say they're on a common vent, so they have to be on a common thermostat, there is additional relays needed, and at which point you do need an external 24-volt source to make that work. Okay, so sequence of operation. The heater always has 120 volts sitting at it, and so the thermostat calls for heat, let's say low stage or high stage. By the way, the heater too, we'll show you a shot of this. There are indicator lights on the back side of this heater that tell you pressure switch, and will tell you low stage and high stage. So let's just say the heater is set to come on in high stage. The thermostat says, hey, we have a call for heat that's drastic enough. We want it to come in full power. The very first thing that you should hear is the fan would activate. So the fan in this compartment here, very rarely do you have to take this lid off, but the fan would activate here. It pressurizes, it blows air in from underneath the gas valve, and it pressurizes and it pushes the air down the tube. Okay, so the fan activates, and then you'll see here a air proving switch or a pressure switch. And so once enough air is generated, there's 2 pickup tubes. There's one downstream of the burner, and then the other one's picking up air where the fan is pushing the air into the compartment. That is a normally open switch, so when that generates enough pressure or the proper pressure, that switch will close. Now, some of the older model heaters, some of the original HL series or some of the HL2 may actually have 2 pressure switches. And on those heaters, there's 2 different compartments. There's a pressure switch in the blower compartment that's normally open. There's a pressure switch in the gas valve compartment that's normally closed, sort of a thing. So some have 2 different pressure switches. They're both in series, so the troubleshooting is, again, very similar. So once the pressure switch closes, it sends a signal to the circuit board. The circuit board in turn will send power to your hot surface igniter, which is under this compartment here. I don't know if you can see that or not. Let me see if I can show you that compartment. And we'll show you a still shot of that. After about 30 seconds, your hot surface igniter will glow orange. You can see it. There's a sight glass window right here. So if you're on a service platform or if you're on the floor looking up at the heater, you would see an orange glow through the sight glass window. So that starts to glow after about 30 seconds. And then about another 20 to 30 seconds after that, actually what should happen is the circuit board should send power to the gas valve. A lot of times you can hear a click. Either in low stage or in high stage, you should hear a gas valve. And then you should now see flame, a blue flame through your sight glass. And if the heater is operating properly, it'll continue to run until the call for heat is over. And then you do have, once the flame goes off, this heater is built in with what they call a post-purge. So the fan will continue to run for about 90 seconds, and then the fan will shut off. It clears all the exhaust gases that are remaining in the tube. So troubleshooting approaches. Okay, the very first thing, we often get calls on these heaters and they're not seeing glow bar or their pressure switch. So the very first thing that should happen is when you activate this heater, the fan should come on. So you want to make sure that you inspect the air intake collar, because sometimes there's a 4-inch air intake collar on the back of this heater, but sometimes they pipe fresh air into the heater from the outside. Let's say it's a dirty environment or it's a car wash or what have you. You have the luxury of bringing fresh air to the heater. Just make sure there's no bird's nest or no obstructions or blockage. Sometimes lint gets built up on the screen, or the fan itself, the fan wheel, and this is where you would want to take this lid off. You do want to inspect your fan wheel, because very often somebody may think they have a bad pressure switch, but it's just the fan's all gunked up and it needs a good clean out. So you want to do that. The other thing you would want to do before you get too far along in your troubleshooting process is also your outgoing tubes, your exhaust tubes or your radiant tubes, because they also could get bird's nest, or on older model heaters, sometimes they get soot inside the tubes. And guys will throw parts at these heaters. They'll want to change out pressure switches or fans and that sort of a thing. But if you have obstructions or sooting inside your tubes, really you have to take care of the root problem first, and then you can proceed from there. So troubleshooting wise, well, let's say we power the heater, we give the 24 volt control voltage, we hear fan, we verified the fans in good operation. Next thing we do, let's just say we're not getting glow bar. So we want to now check this pressure switch, this air proofing switch. So what you could do is you could actually take your alligator clips, or what a lot of technicians will do is they'll maybe just connect the two wires together, ultimately just to treat that like a closed circuit. And then obviously for troubleshooting purpose only, you can't let the heater run like that. And as a matter of fact, the circuit board has a safety built into it. When you first power the heater, it looks for that open circuit before the fan will start, and then it'll look for that circuit to close once the pressure builds up. So if you jump this pressure switch out after the fan is started and now you see glow bar, whereas you didn't before, then the pressure switch is normally the culprit. But again, make sure you don't have those external variables like blockage or in the intake or exhaust. So, okay, let's just say we've gotten past the fan, the pressure switch is working properly, it's opening, closing. Now, let's just say the glow bar is still not coming on. So there's a few things, a few tricks here. You could take the little cover off to the pressure switch. And this is a no tools required. And we'll show you a still shot of this, but there's a little spring that holds this hot surface igniter, this glow bar on. Sometimes you can just take that out and visibly inspect it. If there's a crack in it or a burn mark in it, that can tell you right there it's probably bad. But you could also take your voltmeter, you could unplug the pressure switch inside this compartment here and take an ohm reading on the two pins of the switch, and if it's a good glow bar, you would normally get between 50 and 400 ohms on that. And the other thing you could even do though is also just to confirm you have 120 volts going to this hot surface igniter. You could take your probes and shove them in the back here and verify that you have 110 volts going to the glow bar. Again, you have to wait, let the fan power, let your pressure switch closed. You'll have to wait a period of time and verify that you have 110 going to that glow bar. Now, if you have 110 volts going to the glow bar and it's not working, then that tells you that the glow bar should be changed out. It's bad. So let's just say the glow bar is good. We've gotten this far in our sequence of operation, but we're not getting the gas valve to ignite, or we don't see flame. So we want to focus in on either the circuit board or the gas valve. So what you could do is you could verify voltage going to your valve. And if you take your voltmeter and you go across your common and one of your solenoid, your main solenoid, for example, that's your low fire, on your valve, verify that you have 24 volts going to your valve, but the valve is not clicking or it's not energizing, then that tells you that the valve is bad. If you have 24 volts going to it and it's not opening, pretty much the valve would be bad. But let's just say the circuit board is not sending the circuit board is not sending 24 volts to the valve. Well, then that tells us right there that everything else is checked out until this point, except it's not sending 24 volts to the valve. Then it tells us that you likely have a bad circuit board. So, but let's say that everything else is working to this point. Your gas valve is operating, but you might not get flame for very long, maybe let's say 8 seconds. So normally what that is it's one of two things. If it's a brand new heater, normally it's reverse polarity. Somebody that wired the plug that the heater plugs into, wired the hot leg and the neutral leg reverse, and if it runs for 8 seconds and then shuts off, that tells us that it's probably reverse polarity. The other thing that it may be is there is a little flame rod which is right next to your hot surface igniter. You would want to inspect that flame rod. There's a little 1/4-inch screw that you could take that flame rod out, make sure it's not disintegrated. Sometimes they're oxidized. They have to be cleaned with a terry cloth, put back in. And if that your heater works, then that's your problem. Every once in a while, your flame rod, it could just be a flame sensing issue. You've checked everything else out, but it's still not wanting to verify flame. Your heater still kind of kicks out after that 8 seconds. Then sometimes that could be the circuit board. So if you do all these things and you're still having problems with your heater, that's probably a good time to call us at the number listed, and we can get you all figured out and get you the right parts, and we can get you on your way. So that concludes today's tech session. I thank you for your time. Have a good day.